I'm Jackie O'Brien.
And I'm Sameera Nayak.
And our friend Connie Wang is filming this. Say
hi!
And we're here to show you the physics of a guitar.
Playing a guitar looks easy, but there's actually a lot of science behind it.
There are three components to producing sound on a guitar: the strings, the body, and the air inside.
The strings of the guitar vary by density, length, and tension. The larger the density, the slower the string vibrates. In other words, there's a low frequency. The longer the length of the string, the slower the string vibrates as well. The tighter the tension, the higher the pitch, or the higher the frequency.
This is what you may hear when you're tuning a guitar.
When a string is plucked, a vibration in the air is produced. This is also known as a sound wave.
The speed of the wave is the square root of the string tension divided by the linear density. In an acoustic guitar, the vibration of the string is transferred via the bridge and saddle to the top plate body of the guitar.
The body of the guitar must have a large surface area so that it can push air backwards and forwards in order to vibrate easily, which is why acoustic guitars are usually made of light springy wood. The more the top plate can vibrate, the louder the sound will be.
On the inside of the plates, one will find a series of braces, which are used to strengthen the plates. Without these braces, the top plate would bend and crack under the stress created by the tension in the strings, which would also not be able to push the air very efficiently. The back plate is held against the player's body, therefore it does not vibrate as much and does not radiate much sound.
The air inside the sound hole of the guitar oscillates between compressing and expanding the air inside the body. This forms a Helmholtz resonator. Imagine blowing across the top of a bottle. A tone that sounds like a low-pitched note is produced. This is similar to the lowest guitar resonance because when you compress air, the pressure increases. If the air at the sound hole moves a small distance into the body, it compresses the internal air. The momentum of that pressure drives the air out of the body, and thus it can vibrate like a mass on a spring.
For example, play an open A on the guitar. As the string is vibrating, put a piece of cardboard over the sound hole.
As you can see, the sound is reduced dramatically because the vibration of the air inside the sound hole is stopped. The top plate still vibrates, but it obviously isn't as loud or effective at transmitting lower frequency waves, which is why the Helmholtz resonator is needed.
These are the basic principles of how a guitar works.
And it's a great example of how physics, which you think is just scientific, can be applied to real life to make something that we can all enjoy: music.